Yeah, so Sebastian Steinig, I'm a climate scientist, and yeah, as we're probably all aware, climate change is the biggest threat to modern humans that modern humans have ever faced, right? So it's quite depressing open there, but the good news actually is that climate change is a problem that we can actually solve, right? Because we understand the science behind climate change very well. So we are certain that human activities basically caused the observed warming over the last 150 years. We perfectly know the relation between greenhouse gas emissions and rise in temperatures, and we therefore know exactly what we need to do to stop any future warming, right? Most of our knowledge about climate change, and therefore like the key to the solution about the problem, comes from climate model data. So big models that we run produce vast amounts of data to better understand the past, present, and future climate change, right? And I see as a climate scientist, I see it as my responsibility to share this data that we produce, this essential data, to be able to communicate our results and better to explain to society why urgent climate action is needed. But probably most of you in this room have never really interacted with this raw model data that we produce, but this model data is basically underlying all of our future warming projections and the resulting climate policies. One of the reasons why most of you never really interacted with this data is because most of the time it looks like the output that we generate, the final output looks like on the left. Don't get me wrong, this is perfectly fine if you talk to a room full of atmospheric scientists, it's great, but it just doesn't really cut it for like a 5-minute presentation on a Friday afternoon here. So we need something else. Because these are very complex maps and different layers of geographical data that we're talking about. But if you think about this, something like we are all used to working with maps and geographical data nearly every day, whether it's checking the weather forecast, using navigation apps, or just checking out like the next holiday destination on Google Earth, flying there. So we all use to use this kind of data. And this is basically the whole idea about the Climate Archive project, is taking this very essential data on the left that we produce, we add a user interface that's intuitive and that everybody is quite familiar with, and then we produce something that I would always call like the Google Earth for our climate data on the right, so an interactive version of the data without explaining all of the labels and annotations first, but this is something that jumps directly to the data itself. So that's the idea, and the SeedCon funding basically allowed me to collaborate with Tessa, who is a professional software engineer, to take this idea and transform it into a live website, basically. So this climatearchive.org is live now. It's a free app. It runs on any modern browser, basically, so whether it's a desktop computer or on a smartphone, to make it as easy as possible to access the data, and it's as easy as clicking a link on Twitter. So this basically the platform that we built, and this enabled obviously like a lot of possibilities to connect to new audiences, to groups that I never interacted before, which was super exciting. From school classes to politicians at COP26 trying to convince them about the need of climate action. It also allowed collaborations with museums, where I was able to reach way more people than with any sort of like papers that I published before. But instead of just listing all of these examples that we can use this tool as, for outreach for, I just wanted to like maybe highlight one thing that all of these examples have in common, and this is really, it enabled me in a way to change my way of communication about my research. And it changed it from something on the left, basically having like 30 PowerPoint slides of these maps, piles of maps, and which I would call like sort of like a top-down lecture approach, to something that I would call like always like an explorer mode, basically, because it's super easy, intuitive for people to access the data. Everybody can start interacting with the data right away without any explanation, and this always generates tons of questions with the people. So we'll always start a conversation directly with like a small piece of the big puzzle, with a conversation about something that the user actually finds interesting, found out there by themselves, and therefore we a bit sort of like level the playing field a bit between the scientists and the wider society. So we have a discussion on eye level about this, and then slowly guide the conversation to the bigger picture, instead of starting with this prepared presentation right at the beginning, which normally scares people away. So if we would use Laszlo's eye tracking, probably initially everybody looked on the right side, not on the left side, and everybody was hoping, please don't talk about the left side, talk about the right side, sir. And this is basically all the trick that the project does, but I think it's quite effective, and I'm super excited to try this out for more application in the future, and would be very happy to speak to anybody who's remotely interested in this as well. Thank you.
Questions for Seb out there? I've got one, which is, so you've used this in lots of different kinds of presentations with different audiences, and you talked about COP26 and schools. What are the key differences in the way in which people are responding to the interactive in those different kinds of audiences? I'm just interested in the reception of it.
Yeah, normally like this really works best like the younger the people are, so like school children, students are super excited about this because they just start trying to interact with this. A lot of people just approach me and think like, oh, that's a strange video game, what do I have to do with this? This is always a good opener, and with this normally it really helps also like to attract, then basically get into a conversation and then also speak to the parents about the problem as well. I think there's, therefore like it's sort of like this touch first generation, it works best about it. But the thing is like always, depending on type of conversation, like this is basically nice as a beginning, but if I then have like our audience like talking to politicians, we can always fall back to some specific parts of our like more standard output to back up these things, because I also experienced that some people say, okay, well, it's nice, colorful, shiny and stuff like this. This doesn't look like real science anymore. But we can transition between these things depending on the opposite, basically, who I'm talking to, basically.
That's really interesting, thank you. Any other questions? Yeah, Laszlo.
So I just opened the website, and I've seen that you modeled Dune as well, the planet from the movies. Are you planning to add other planets as well?
So I have to give credit to Alex Farnsworth there. So Alex did the actual modeling of Arrakis, basically of the Dune world, and yeah, we do several of these fantasy planets basically just to be able to show how flexible our climate models are, because normally one response I always get at public exhibition is always like, your models, first of all, I don't trust them, it's very common, but then people say like, okay, they are just tuned to produce some warming in the next 20, 30 years to scare people and so on. But what we try to show is basically we can take the same model that we use for these future projections, we can apply them for the last 500 million years, compare this to the data, we can apply them into fantasy planets and still basically simulate the climate system based on very, very simple, just a handful basically of base equations derived from pure physics. This is a way of how we think we can reach like different audiences that are not really interested in climate science itself, but they are fans of like Dune, or we did Wheel of Time as well. And there will be some more worlds. We also did Game of Thrones and Lord of the Rings, so there will be more coming. But basically, it's a good way to just attract different audiences that normally never would think about climate research, and then on the back of this, basically explain a bit about the science and how we use these tools for the actual research, basically.
I mean, when I first looked at it, I thought, oh, okay, we can look at Star Wars and we have a lot of material there. But then I thought, actually, like, could you do Mars? Because that's a good example of a giant climate catastrophe, I guess. I don't know if the data is there yet. It's still very much.
Yeah, Mars will be there this summer as well. So, but for Mars, it's basically what we're using is there's like a lot of actual like reanalysis data, because we can measure actually from Mars. We can obviously not as densely as for the Earth, but there's like good set of like observational reanalysis data, and we're adding Mars there as well. People are interested in putting like exoplanet simulations there. You could think about all sorts of things, because this data format that we handle is quite similar and quite well-defined and standardized basically in our community. So the idea is really to open up the platform to make it much easier to get this type of data, global climate data, onto the platform, because at the moment it's a bit more tedious work for me basically, but hopefully the next step to open this up, to automate this process would help other people to use this platform basically to communicate their own data in a hopefully new and exciting, more engaging ways as well.
Great, thanks.
Yeah.
Other questions? Okay, thank you very much, sir.